Today we'll discuss about the material balance around stripper, that is a side stream stripper in the atmosphere distillation column. So we all know about the atmosphere distillation column side products. So in our example we have taken the side products. There are three side products we have taken. One is heavy naphtha, one is light distillate, and one is heavy distillate. These are the three side products, and there is one top products, that is a light naphtha. So especially for the side products, what is happening, we cannot obtain the side products of the given specification from the distillation column. So normally what happen, always there are lighter fractions available with the products. For example, if you see closely, you will find that for all products, this is the basically location from where we are drawing the products from the column. This is the location, and for the heavy distillate, this is the location. So these are the locations, these are the streams that is recovered from directly from the atmosphere distillation column. All these have the lighter fractions, means all these streams contain the lighter fractions, and we have to remove these lighter fractions to match the specification of all these products. So for example, if we are taking the heavy distillates, so the lighter for the heavy distillates are light distillate, heavy naphtha, and light naphtha. These are the lighter than the heavy distillates. So in the heavy distillates, a small portion of light distillates are present when we are recovering from the atmosphere distillation column. Similarly, for the light distillate, a small portion of a heavy distillates are present, and for the heavy naphtha, a small amount of light naphtha is present. So we have to remove that lighter fractions. Therefore, to tune the side distillates or to remove the lighter fractions, necessary stripper is necessary. We have to put the stripper from where we can remove the lighter one. So you can see if in the graph, for example, in this graph, it is very clear that this, in the feedstock, we have taken the lighter one is returning back into the column. This is a lighter one returning back into the column. So lighters of every product is returning back into the column, main column, atmosphere distillation column. Only the desired specified products are taken out from the stripper. So in our case, we have the strippers. So stripping is carried out either with the help of steam or reboiler. In the given problem, all the side distillates are the steam stripping. We are providing the steam. This is a steam that is provided for every products during the stripping cases. So steam is there basically to remove the lighter fractions from the side strippers. So this is a story about the importance and significance of side strippers. Now come to the next one, that is a calculation. So how to go for the material balance? So for the material balance, this is a one simple example. Normally the material that is entering into the stripper, that material is known as a feed. It can be any stream, can be a light naphtha, heavy naphtha, but this is known as a feed that is entering into the stripper. Then with the help of steam, one lighter fractions, that is a strip out vapor, is recovered from the top, and the remaining material, that is a product in the form of liquid, is returning from the bottom. So feed is entering, and in the form of vapor, lighter is recovered from the top. In the form of liquid, liquid products are recovered from the bottom. So that is the first thing that is happening in the stripper. How to calculate the material balance? So these are the steps. The first step, we have to assume that the product, that is D, that is the bottom of the stripper, is taken as 100 pounds per barrel. That is the assumptions. We can then use that value to scale up. So first assumption is we have to assume that D is 100 pounds per hour, that is the flow rate of D is given, and obviously the specification of this product is also given. It can be a heavy naphtha, heavy distillate, light distillate. And then find out the SF strip out factor from the steam flow rate. Next step, how we can find it? With the help of the graph. And then we have to next step find out the flow rate of the F with the help of the definitions that we have discussed about how to find the feed, and then find out the VSO by subtracting it. So now let us look over how to find the F. So F can be calculated with this formula, simple, D upon 1 minus SF. D is given, SF is calculated, find out with the help of graph. So F can be calculated by this one. Because this is a basic definition, F is into 1 minus SF is equal to D, and then F is equal to D upon 1 minus SF. Remaining is VSO is F minus D, amount of feed minus amount of product is given the VSO. So this is a step. Now let us take the example. So before example, how we can find out the SF? This is a graph for the calculation of SF. For example, in our case, the steam is given as 10 pounds per barrel. So at the 10, for example, we are going for the naphtha, that is the heavy naphtha. So at the 10 flow rate of steam at x-axis, we have basically very close look about here. It comes very close to the 20, but not exactly a 20. It is about 18 and 18.5%. So we can say the y-axis is 18.5%, and if we convert it 18.5% in the fraction, so at the SF value is basically 0.185. It's okay. Now come to the next step. So just remember that for the naphtha we have HF value we have calculated. So product, this is given for the product. What we have given, the range of product is given. This is a heavy naphtha. The range is 12.7 to 23.5 initial to final range, and the yield is 10.8 volume percent. So this is given. We have to assume first 100 pounds per barrel the product we are recovering, and we know the SF value of steam is 0.185. So we can find out the F value, and we can represent these basically informations of the product and heavy naphtha in the graph. Like for example, this is an initial range 12.7 to 23.5. So initial range 12.7 to 23.5. This is about the D. And if you look about the value of F, so F can be found out simply by D upon 1 minus SF. So D is given 100 upon 1 minus SF value is given. We can find out F is equal to 122.7 pounds per barrel per hour. So F is given. F location is because F having the lighter, so lighter than the 12.7 will be basically in the left side of the graph. So this is the F value. So the remaining portion that is still missing is that basically VSO. So this is the whole picture of F, D and VSO that is representing in the graph. But calculations, so we can find the VSO very simply by dividing from the feed. So feed is 122, bottom is 100, remaining is VSO, that is 22.7 pounds per hour. So in this way, this is the first step. This is basically the flow rate calculations for all these three streams, three hydrocarbon streams that is available streams. As far as steam is concerned, steam is here. We are not going to use the steam in the material balance. Later on we can use the steam for the energy balance. So ignore the steam here, but all these three streams, feed streams, product streams and vapor streams has been calculated. Okay, now come to the next step, how to find the range of all these one. So this is a one correlation, simple basic concept of if the 100 pounds per hour of material from the crude oil is representing the 10.8 volume percent. 10.8 volume percent is the yield. Say in the naphtha yield is 10.8 volume percent. So yield is given here basically. So if the naphtha volume 10.8 volume percent, so that is what I am basically showing you here. So we have taken the 100 pounds per hour of this yield. So What about the feed flow rate? Feed flow rate is 122. So if 100 is representing 10.8 volume percent in the crude, so for the 122.7 it will represent 100.8 divided by 10.8 divided by 100 multiplied by 122.7, that comes around 13.25 volume percent on the whole crude basis. This is the value of feed, that is the yield of feed in the crude oil. So that you have to be careful, that is the important step. So in this way we can find out 23.5 and 12.7. this is about the D, and the yield is 10.8. now we have to find out F value, and if the F value is 13.25, then we can find this value, that is the volume percent of the initial range of feed. Is very easy, just minus 23.5 minus 13.25, so that gives 10.25 value. So now in this way we have find each and everything. The feed range is 10.25 to 23.5, VSO is 10.25 to 12.7, and D, that is given 12.7 to 23.5. So you can say for the feed in heavy naphtha, their flow rate is calculated, all these flow rate first step, and then second step with the help of this yield we have calculated yield of feed and VSO, that is basically here VSO, it should be a VSO, that is a mistake, it should be a VSO. Similarly, the range, initial range, this final range is calculated, it is given, basically green color is given, and this range is calculated. So simply by giving the three values, one is assumption 100, one is initial range and final range, we can find the flow rate of other streams, yield of other streams, range of initial and final ranges of other streams. So this is all about how to carry out the material balance. So your task is basically to find out that we have carried out for heavy naphtha, your task is to find out all these values for the light distillate and heavy distillate. These ranges are given here for light and heavy distillates, and we have assumed the 100 pounds per hour flow rate. You have to fill all these remaining entries. Okay, thank you very much.